In your Chapter 1 readings, we look at just how big our universe is. In the book, The Hitchhiker's Guide to the Galaxy, Douglas Adams writes that space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemists, but that's just peanuts to space. If you've ever read this book or watched the film, you'll have a glimpse into my weird sense of humor. But Mr. Adams is not exaggerating. In fact, the universe is so immense that we actually have to use units that are much bigger than inches, feet, yards, and miles to even begin to make sense of how awesomely big it really is. The word awesome literally means that you are in awe, wonder, or disbelief at the scale and scope of something. The universe is so huge that human brains really can't comprehend the size. So we're going to take a look at what things look like as we zoom out from home. In the upper picture, we see individual homes as if we're flying a drone over them. Below that image, we see the same neighborhood as if we're looking out an airplane window from a much greater altitude. We can still see a few roads, but the houses aren't nearly as clearly defined. We're getting too far away to see them clearly. On the right, we see the image of the entire state of Florida. On this scale, we cannot see the homes or roads at all, and we can only distinguish land from water. We use the unit kilometers to measure distances on Earth or out to the distance of the moon. I will occasionally give you numbers in miles, but we typically don't use the unit of miles in science classes. We use metric units like kilometers. As we continue to zoom out, we see the entire globe of the Earth with our little corner of it over on the left. The Earth seems big to us compared to our everyday experience of driving around on it. Here are listed some fun facts about the Earth, but you don't need to memorize any of these numbers. Earth is mostly made of rock, is roughly spherical, and is about 12,700 kilometers in diameter. A kilometer is 0.62 of a mile, or a little bit over half a mile. If you were driving at 100 kilometers an hour, or about 62 miles an hour, it would take you 17 days to drive all the way around. And that's a pretty long time. Light, though, travels much faster than a car can. At the speed of light, you could go all the way around the Earth in only 0.13 seconds. Moving away from Earth, we see the images of the terrestrial inner planets. These are the rocky planets that are closest to the sun. These planets are Mercury, Venus, Earth, and Mars, sized to the correct scale. Notice that Earth is the largest of the terrestrial planets. Venus is pretty close to Earth in size, but Mars and Mercury are much smaller. We will talk more about each of these planets in detail in Unit 2. Moving a bit farther away, we get to the outer gas giant planets. These planets probably have a rocky core deep down, but they are mostly big balls of gas. The four gas giants are Jupiter, Saturn, Uranus, and Neptune. For scale, this image also shows you the size of the Earth, Pluto, and its largest moon, Charon. Although Pluto is no longer classified as a major planet, we will talk about it in this course. Notice how large Jupiter is compared to the Earth. All these planets orbit around the Sun. The Sun is much larger than all the planets combined. Remember how big Jupiter was compared to the Earth? Now look at how small Jupiter looks compared to the Sun. The Sun doesn't look that big to us in the sky, though, because it is so far away. In fact, it's about 93 million miles away. When talking about numbers that big, it's easy to make mathematical errors. So we invented a new unit called the AU, or an astronomical unit. An AU is defined as the distance between the sun and the Earth, or 150 million kilometers on average, or again, about 93 million miles. This is super important, and we'll use the AU unit a lot when talking about distances in our solar system. The sun's diameter is 109 times bigger than Earth's, and over 1 million planets the size of Earth could fit inside the sun. Again, you don't need to memorize these specific numbers, but the numbers are helpful in realizing how much bigger the sun is than the Earth. In this picture, you can see a huge loop-shaped storm on the sun. The Earth is so small in comparison to the sun and this storm that you can barely see it in the picture. An astronomical unit is so long that you'd have to line up almost 12,000 Earths end to end to span that distance. Zooming out from the sun to see the whole solar system, we see the inner rocky planets closest to the sun and the gas giants much farther away. You can also see Pluto on its inclined or tilted orbit. These planets are so far away from the sun and from each other that we don't use kilometers or miles to measure the distance. We use astronomical units, or AUs. You can see that the inner rocky planets are no more than 2 AUs away from the sun, while the outer gas giants are about 5, 10, 20, and 30 times farther away from the sun than the Earth is. That's why outer space is called space. There's a lot of space between these objects. Light is the fastest thing we know of. Light travels at a speed of 186,282 miles per second. At that speed, it only takes the light about 8 minutes to travel the 93 million mile distance from our star, the sun, to the Earth. But if we wanted to talk about the distance to much farther stars, we wouldn't use kilometers, miles, or even AUs. We would use a unit called the light year. A light year is the distance that light travels in a year. Be careful. Even though the word year is in the name, a light year does not measure time, it measures distance. The closest star to the sun is called Proxima Centauri. Light from this star takes over 4 years to reach us, even traveling at 186,282 miles per second. This star is 40 trillion kilometers, or about 25 trillion miles away. And that's the closest star to us other than the sun. So it's important to keep in mind that stars that seem to be close together to each other are actually usually very far away from us and from each other. We will talk a lot about the sun and other stars in Unit 3. Now, zooming out away from individual stars or groups of stars, we begin to see our galaxy, the Milky Way. The Milky Way is a spiral-shaped galaxy that we're seeing here from the edge-on or side view. Below it, those 2 smudge blobs are the Large and Small Magellanic Clouds, 2 much smaller galaxies that orbit around the Milky Way. These types of small galaxies that orbit a large galaxy are called satellite galaxies. We'll talk about galaxies in Unit 4 of this course. This is another image of a spiral galaxy seen in the front-facing or face-on view. We don't have a picture of the Milky Way from this view because we can't take a picture from inside the galaxy. But this galaxy is probably roughly what the Milky Way looks like from the outside. Light travels about 6 trillion miles a year, and it would take close to 100,000 years for light to travel the entire length of the Milky Way. It is huge. Still, there are other structures that are much larger than the Milky Way. As we zoom out farther, we see 2 more large galaxies: Andromeda, that we mentioned back in the Seasonal Skies lecture, and Triangulum. These 3 large galaxies and the dozens of other small ones surrounding them make up what is called our local group. At the top of the image, you can see the distance scale showing you how far 1,000,000 light years is. Andromeda is the closest large galaxy to the Milky Way, though there are other smaller galaxies that are closer. If you're in a very dark location, you can even see the Andromeda galaxy in the sky without a telescope as a small blurry smudge. But it is so far away that it takes light about 2 million years to reach us from Andromeda. You can see a couple of Andromeda's satellite galaxies in the photo as well. Sometimes another unit, called the parsec, is used to measure these long distances as well. A parsec is about 3.26 light years. We'll talk about why that unit is used and what it actually means later in the course. Now, if we continue to zoom out, keeping the Milky Way and Andromeda centered on the page, we start to see other groups of galaxies, like the Ursa Major groups and the Virgo cluster. Light from this Virgo cluster has taken 65 million years to reach us. That means that the light that we see from this cluster of galaxies tonight left the clusters when dinosaurs still roamed the Earth. That also means that if there are technologically advanced aliens in those galaxies with super powerful telescopes looking at the Earth, they aren't seeing us. They're seeing dinosaurs because the light they're seeing left the planet so long ago. Though the universe continues out much farther even beyond these clusters of galaxies, hopefully you can see just how truly big the universe is. Keep in mind that the sun is about 150 million kilometers or 93 million miles away from the Earth. The bright stars we see in the sky are about 1,000,000 times farther away from us as the sun. Even the nearby galaxies are 100,000 times farther away than these bright stars. Again, the specific numbers aren't important, but it does give us an idea of how awesomely big the universe is just by looking at these humongous numbers. And finally, this is an image taken by the Hubble Space Telescope. It's called the Hubble Ultra Deep Field. These galaxies released their light approaching 13 billion years ago, and they represent some of the most distant objects we can see. We will look at this image and a more recently taken image from the James Webb Space Telescope in upcoming lectures.